Hello everybody. For today's homework, I chose from section 3.4 the example number 1. The reason why I chose this one is because when I first read Dress notes, it says that this chapter should be easier. We understand 3.2, 3.1, 3.2, and 3.3. But when I first read this problem, I felt that I was not going to be able to understand this. After I actually stopped, read it a little bit better, and start trying to resolve it. So here we go. So the first thing that we're going to get from here is the S equals f of t equals t squared minus 4t plus 3. So that's going to be the first thing that we're going to get. And we're also going to be using this piece of information. Okay. So one of the very first things that I'm going to do is that if at any point we take t equals 0, we also know that the variable of t plus t is going to equal the maximum value, that's 7. So for this, we know that the variable of t, when t is 0, will be 7. We are asked to find the displacement. And so for the body displacement, we know that that's going to be the variable of s. And the variable of s is going to be the function of the variable of t plus t minus the function of t. So we do know that the variable of t plus t, it's going to equal 7, like we can see here. So we know this is going to equal this. So that's what I'm going to use. So it's going to be f of 7 minus f of 0. So then this is going to equal, using the f of t that we have, so 7 squared, that will be 49, minus 7 times 4, 28, plus 3, minus, now 0 squared, it's 0, minus 4 times 0, it's 0, plus 3. So then this will equal 24 minus 3. And this will equal 21. So here we have our displacement. And this is in meters. Yay. Now the second thing that they're asking for us to find is the average velocity for the given time. So now for the average velocity, what we are going to do is we know where is the displacement, and that, so for the average velocity, we know average velocity will equal the average of s under the average of t. So the average of s, we know it's 21, and the average of t, we know it's 7. So this will equal 3. Yay! So we have the answer for the first question. So the displacement will be 21 meters, and the average velocity is going to be 3. So now let's go to question B. So B is asking us to find the speed and the acceleration. So for the speed, we know from the previous chapters that is going to be function of t equals, oops, this doesn't look too good. So let's do this again. So it's going to be the function, the function of t is going to be the velocity. So knowing this, we know that f of t equals t squared minus 4t plus 3. So with this knowing, I will use the different rules that we were taught on the videos to actually do the derivative of f of t. So that will be 2t minus 4. So that's going to be our velocity. And now it's asking us to find the speed and acceleration at the endpoints. And we knew that we were having that t is bigger or equal than 0, but smaller or equal than 7. So for t0, we will know that f(t) equals minus 4, and that for t7, the velocity is going to be 14 minus 4, so 10. And because it's velocity, it has to be an absolute number. So the absolute of 4 is going to equal 4, and the absolute of 10 is going to equal 10. So those are our two answers for the speed. Now we need to find out the acceleration, and we know that for the acceleration, that's going to be the derivative of the velocity. So we're going to take the velocity form here, and we're going to do the derivative of this one. So we're going to just call this one acceleration. T will equals. So we're going to again use the same formulas that they taught us on the previous videos to get the derivative of an equation. So for here we will have that the acceleration of t is going to be 2. And we know that the acceleration is going to be a constant. So then we know that the acceleration at the beginning and at the end of the intervals is going to be the same, 2. So here we have the two answers for question B. And now we proceed to question C. They're asking us when, if ever, during the interval does the body change its directions. So what I'm going to do with this one is we're going to use the equation that we have for the velocity. So we're going to do f of t equals 2t minus 4. And what we're going to do is we're going to take 2 points, 2 different values for t, and see what are the directions that they're taking. So first I'm going to take, let's say, when the time is 1, then the velocity is going to be 2 times 1, so 2 minus 4 minus 2. Then when t2, the velocity is actually going to be 0. if we take, let's say, t4, the velocity will be actually positive 4. So since we're seeing that there is a difference on the signals, we go from -2 to +4, then that means that there is a change, and the change happens when t is 2. So that will be the answer for C. And that's it. Please let me know if you guys have any other questions, and hope you all have a good night. Bye bye.